So now in this video, we will be covering all the important type of questions which are frequently asked in board exam and which have been asked over the years. So the first question in this league is this particular question. The question is written over here. Fx is equal to a and all this particular thing. This is a different type of question that we have not touched so far. So what we are supposed to do is we have to find the value of f of 2x minus f of x. Now fx is given and we have to find the value of f of 2x minus f of x. So first thing that I'll do is I will find the value of fx. So I'll try to solve it in the form of determinant. Since fx is a determinant, so I'll try to solve fx in the form of determinant by applying the properties that we have learned. So what do we observe in the first column? I can take a common. So let's start the solution. So what I'll do is for f of x, I will take a common from column 1. So what I'll be left with? This particular thing over here. So now what do I observe? To find the value, I need to expand. Expansion becomes easy when I have two zeros along any row, any column. So over here, what do I observe? This is 1, this is minus 1. So if I add both the columns, I'll be getting 1 0 definitely, right? So I'll write C2 such that C2 plus C1. So it will give me A. This will be 1 x square unaffected. This will also be unaffected. Over here, I'll add these two. This will be 1 minus 1 a x plus a and x square plus ax. Now, what do we observe? I can take x common from here. So, I'll work on that. Whatever things come to our mind, we will keep on working on those particular things. So, over here, this is x plus a. If I take x common here, I'll have x plus a. This is 0 minus 1a. I can take x plus a common from column 2. Right, so it will be a x plus a common from column 2. So this is 1 x square 0 1 x 0 minus 1a. So now we observe we have two zeros along row 1. So I can definitely expand. So let me expand and see what I am getting. So what answer we are getting for fx? It is a x plus a whole square. So if it is f of 2x, what am I supposed to do? I'll just replace x by 2x. So I'll get a 2x plus a whole square. Now what we are supposed to find? We have to find f of 2x minus f of x. This question was asked for 4 marks in 2015. So again, very important question. So f of 2x will be a 2x plus a whole square minus ax plus a whole square. Now what I can do is, yes, you are right, we can open up the whole square. So this is 4x square plus a square plus 4ax minus ax square plus a square plus 2ax. Applying the formula a plus b whole square. Now let's multiply and open up the bracket. So what we'll get? This 4a square x minus ax square minus a cube minus 2a square x. Let's see some of the terms are getting cancelled or not. A cube and a cube can get cancelled. Over here I can just write it up simplifying. So this will be 3x square a and this will give me plus 2a square x. Hence the solution. Next very important question. This is also one of the solved example of NCERT. Very important question, often asked for 6 marks. What is given in the question is x, y, z are different from each other and the value of the determinant is given to be 0. Now what we are supposed to do is we have to show that 1 plus x, y, z is equal to 0. So let's proceed. We have to keep this thing in mind. Since determinant is given to be 0, so I'll start the solution with the determinant. So given a determinant like this, now what I'll do is I'll write it as, we can always split it into 2 since the column is written as sum of 2 elements. So I'll split it into 2. We will write it as x, y, z, x square, y square, z square. And this will be x cube, y cube and z cube. Now, first determinant I'll write as it is. From the second, what do I observe? I can take x common, y common and z common, right? So I'll take x, y, z common from the second determinant. So it will be x, y, z common. What I'll get? 1, 1, 1, x square, y square, z square. Now what do you observe? Are both the determinants same? Yes, exactly. Both the determinants are same with the placement of terms in the different columns. This is the difference, basic difference. Over here, this is, one is column 3 and this is column 1 over here. So how will I make both the determinants equal? Yes, we have done the properties. I can always interchange my rows and columns. How will I do it? I will interchange column 3 with column 2 and then column 2 with column 1. So this is how I'll interchange the first determinant. So column 3 with column 2. So this will be 1 and this will be x square, y square, z square. Then column 1 and column 2. So we will have 1, 1, 1, x, y, z, x square, y square, z square. Now we have done one property. There is a catch over here. We have done one property which says if we interchange columns and row, the sign of the determinant changes. So now, how many times did I change the column here? 2 times. So I will have 2 minus sign, which will again have no effect on the question. So, but why did I write this? So that you know that we know the property and we can apply it over here. So it is minus 1 whole square. Had it been only one change in the operation column, I would have taken only minus 1 common. So then I'll write this as it is. This is x, y, z. This is 1. This is x square, y square, and this is z square. Since both the determinants are same, so I can take it common. If I take these two common, so I'll write it once only. If I take these two columns, these two determinants common, I will write them once, and within bracket, I'll write whatever will be left at the first place. So if I observe the first place, what will be left over here? 1, and for the second place, it will be x, y, z. So this will be getting, and all the things are equal to 0. So this whole thing is equal to 0. Now what we have to prove? We have to prove that 1 plus x, y, z is 0. Now what do we know? If the product of two numbers is equal to 0, either of the two numbers are 0. Over here, if I have to prove that this is 0, I have to be sure that this is not equal to 0. Remember, we have to prove that the value of this particular determinant is not equal to 0. So the whole focus is now on what? To prove that this particular determinant is not 0. Now what do we, I observe, what do we observe? We have all the elements 1 along column 1. So I can definitely make 2 zeros over here. Again, we will keep the same. This element I will fix and the rest of the 2 I will make 0. So what operation do we generally apply? So I will write R2 such that R2 minus R1 and R3 such that R3 minus R1. So I will fix R1 and subtract it from both R2 as well as R3. So this will be 1 x square, this will be 0, this will be y minus x, this will be y square minus x square, this will be 0, this will be z minus x, this will be z square minus x square, and this is 1 plus xyz equal to 0. So now again what I will do, can I take anything common from here? The same lines we are almost there. So this is y minus x, this is z minus x. I am taking it directly. So this is 1 y minus x common from R2 and z minus x common from R3. So let's see what will be left if I take these common. Over here it will be 1 y square minus x square. If I take y minus x common, what will be left? If I apply the identity a square minus b square, it will be y plus x. So this will be y plus x. Over here this is 0, this is 1, and this will be z plus x. This is 1 plus xyz is equal to 0. Now I'll just expand, or you can apply one more property by making it 0. I can expand over here also. So if I expand, what will I get? Cross multiply these two. So it will be z plus x minus y minus x, and this will be 1 plus xyz is equal to 0. X and x will get cancelled. So what will I have? X minus y. So now let's observe what we have. So what we have is over here, let me quickly write it. So what we have? Y minus x, z minus x, and z minus y. Now what was the first line of the question? X, y, z are all different. All different means, let's say if it is 1, 2, 3, if I subtract them, y minus z, z minus x and z minus y will never be 0. Very important. So since x, y, z are all different from each other. Let's take an example, any three numbers. If I take 1, 2, 3, 2 minus 1, 3 minus 2 will never be 0. So similarly, since these three are different, y minus x, z minus x, z minus y will never be 0. All the three factors are non-zero. Therefore, the fourth factor, which is 1 plus xyz, is 0, and hence the result. Next, very important question, again a 6 marker, solved example of NCERT, frequently asked in exam. Now what is the different condition which is given over here? A, B, C, three terms, they are positive and they are unequal. They are positive as well as they are unequal. We have to prove the value of the determinant is negative. We don't have to find as such the value of the determinant. What we have to prove that it is negative. So given a determinant, so obviously I have to start my solution with the determinant. So I'll start with the determinant. Now what do we observe in the determinant? All the terms are alike. So I can add it along any column, any row, I'll get the same expression. So let's start. So what I'll do is, I'll write C1 such that C1 plus C2 plus C3. So if I write it like this, what will I get? I'll get A plus B plus C, A plus B plus C, and A plus B plus C over here. The other terms will be same. So now once we have something similar, I can always take it common. The same lines which we are working on. So this is 1, 1, 1, B, C, A, C, A, B. Now what do I observe? 3 ones. So the best thing that we can have in a question when we have 3 ones, so I'll fix this, make these two zeros. So I'll write R2 such that R2 minus R1 and R3 such that R3 minus R1. So what will I have? The first row will be same. This is 1 minus 1, 0. C minus B, A minus C, 0. A minus B and B minus C. Now what we have to do? We cannot make further zeros, so I will expand. So let's expand. So whatever we have in factors, I will not multiply. I will just keep it as it is. If I expand it along column 1, what will I get? C minus B multiplied with B minus C minus A minus B multiplied with A minus C. Now let's open up the whole thing. So let's see, A plus B plus C. So this will be, what do we observe? If I take minus common, this will be B minus C whole square. So I can write this as minus of B minus C whole square. I'll open up. So B square plus C square minus 2BC. Clear? I have taken minus common here. So this is B minus C whole square. Minus is over here. So what is the formula? B square plus C square minus 2BC. Over here, I'll just multiply. So it is A square minus AB minus AC plus BC. Now I will open up the negative sign. Let's expand all the terms. So what will I get? This will be as it is, A plus B plus C. And this is minus B square minus C square plus 2BC. This is minus A square plus AB plus AC and minus BC. So now let's see what we are getting. Now if I observe this particular expression closely, now what do I have? I can think of the formula A plus B plus C whole square, A square plus B square plus C square, but all the terms are positive over there. So what I'll do is, I will take minus common. So if I take minus common, what will I get? I'll write this as minus common outside this A plus B plus C, and the rest of the elements I'll write arranging with the higher powers. So A square plus B square plus C square plus this plus 2BC and minus 2BC will be plus BC, and if I take minus common, this will be minus BC minus AB and minus AC. So here is the catch. For the whole question, up till this, most of the students are able to do. After this, there is the basic difference that everybody has to keep in mind. So A square plus B square plus C square. Now if I have to prove that the value of the determinant is negative, I have got the negative sign outside. Can I conclude after it? Definitely no, because I know for A plus B plus C, these three terms are positive, so their sum will be positive. So this whole term is positive, this I am very sure. But I don't know about the fate of the other expression. How? because I know a plus b plus c are positive. I know a square b square c square is positive, but I don't know whether this expression will be greater or the negative expression will be greater. Clear? So therefore what I have to work on now to prove that this whole thing is negative, I have to work on that this whole thing is positive. Clear? I know this is positive. Now what will be my working? My working will be on the point that this whole expression should be positive. Now how can it be positive? If I have whole square. So what I'll work on now? Making it as whole square. So to make it whole square, now what I'll do is I will multiply and divide by 2. So I'll divide by 2, I'll write it outside. If I multiply it by 2, it will be 2a square, 2b square, 2c square, minus 2bc, minus 2ab and minus 2ac. Right? So now let's see, for 2a square, what I'll do is, I'll write it as, this will be as it is. 2a square I'll write as a square plus a square. 2b square I'll write it as b square plus b square. 2c square I'll write it as 2c square plus c square, and the rest of the things I'll write as it is. Now the basic point that we have to keep in mind now here is, what I have to do is I have to work on making the whole expression whole square. I cannot write it as a plus b plus c whole square because I don't have 2 over there, and the signs we cannot adjust. Therefore what we are doing is we are breaking it and trying to make 3 whole squares. How? Just see, it is 2bc. So 2bc comes in the formula of b square plus c square. So if I take all these 3 terms which I have colored as orange, I'll get the formula of b minus c whole square, right? What is the formula? B square plus c square minus 2bc. Clear? Now, if I take these 3, what is the next term? Minus 2ab. So if I take a square, b square and minus 2ab, what will I get? I'll get a minus b whole square, which we can write as b minus a square, c minus b square. It will hardly make any difference. Clear? Now the left out 3 elements will give me a minus c whole square. So right, we are there. What we were working on, we were trying to prove that the value of the determinant is negative. Now we have got the solution. How? Let's see. Since a, b, c, what we will write? Since a, b, c are all positive and they are different from each other, so definitely a plus b plus c will be greater than 0. Now for this particular thing, b minus c whole square will be greater than 0. It will not be equal to 0 because a, b and c are all different, so it cannot be 0. Similarly, a minus b whole square and a minus c whole square will be greater than 0. So all the terms that we have in the determinant are positive. We have minus sign outside, so it means that the value of the determinant is negative. Hence proved. Very, very important question. Go through this particular question 2-3 times. You will be able to understand that particular catch over there. Clear? So next important question. Again, most of the time a 6 marker. Sometimes it can be asked as a 4 mark question. Very, very important question. Now for one particular solution, we have 2 types of question, and the working for both the question is exactly the same. You only have to identify the type. This is a solid example of NCERT, and this particular type was asked in the board in 2010. So very, very, very important question. So now what we have to observe over here? It is b plus c whole square, and this result I have to get, that is a plus b plus c whole cube particular thing. Over there, just observe what is the difference in this particular type and this particular type. This is b square, c square, all the terms are in square, and here all the terms are not in square. So here we will have one more step extra, that is we will multiply this particular row by a, this particular row by b, and this particular row by c, and ultimately I will get this type of question. So very important, you have to keep all these things in mind, that if we have whole squares, we have to change everything to whole square so that we can apply the formula a square minus b square, right? So I'll start with this particular solution. So what we will do is, I have the workings that we generally adopt is, can we take anything common? No, definitely I cannot add everything to get particular expression. So what I will now work on is to get that particular expression, and when we have all the terms as whole square, it becomes easy for us to apply the identity. So I can subtract it anywhere around. So I observe this is a square over here, and this is b square and b square over here. Similarly, we have c square over there. So I'll fix this particular column and subtract it from here. So I'll write C1 such that C1 minus C3 and C2 such that C2 minus C3. So we'll fix C3 and subtract it from C1 as well as C2. Over here, if this would have been the question, I would have written one step, that is A R1, B R2 is B R2 and R3 is C R3. I would have multiplied the determinant by, divided the determinant or multiplied the determinant by 1 upon ABC. And then next step I would have taken this A common, B common, C common. I would have got the same question, and then I will proceed in the same manner. So you have to remember all these things. So now what I'll do is, I will write B plus C whole square minus A square. So this is whole square minus A square. This B square minus B square will give me 0. This is C square A plus B whole square. This A square minus A square will be 0. C plus A whole square minus B square. C square minus A plus B whole square. And this is A square, this is B square, and this is A plus B whole square. So now once we have A square minus B square, we'll apply the identity. So what I'll get? B plus C minus A. B plus C plus A. This is 0. This is C minus A minus B. This is C plus A plus B. This is 0. This is C plus A minus B. Applying the identity. C plus A plus B. This is C minus A minus B. This is C plus A plus B. This is A square, B square, A plus B whole square. So now what I'll do is, I'll take A plus B plus C common from here. Similarly, I'll take A plus B plus C common from here. So we can take it common from two columns. That is why what I'll have A plus B plus C whole square. So this will be B plus C minus A. This is 0. This is C minus A minus B. This is 0. This is C plus A minus B. This is C minus A minus B. This is A square, B square, A plus B whole square. So we have reached up to this particular step. Now what we have to work on further is, now can I have further zeros, or can I simply reduce this particular expression? So now what do I observe? This is A plus B whole square. And this is A square plus B square. So if I add up these two rows and subtract it from here, I'll have some sort of reduced expression. So next step what I'll do is, I'll write it as R3 such that R3 minus R1 plus R2. R3 minus R1 plus R2. So I'll do it over here. So what we will have, A plus B plus C whole square, and this will be B plus C minus A as it is, 0, A square as it is. This is 0, this is C plus A minus B as it is, this is B square. Now, this is C minus A minus B. If I add up these two rows, I'll get B plus C minus A. So let's see what we will be getting. We will get, I'll just simply write it over here. We will get C minus A minus B minus C plus A. After applying the negative sign also. So I'll just simply cut A and C and C. So what I'll have minus 2B. So I'll write it over there. This is minus 2B. The same thing applies to this, C minus A minus B. So what will happen to this? I'll simply write C minus A minus B minus C minus A plus B. So over here B and B will get cancelled, C and C will get cancelled. I'll have minus 2A. So I'll simply write minus 2A over here, and this is A plus B plus C A plus B whole square. So minus, if I subtract A square minus B square, I'll get 2AB. Now I can further take 2 common from here. So now let's quickly solve it up. So what we will do is, over here I observe from R3 we can take 2 common. So let me quickly write it over here. I'll write, we will take 2 common. So it will be 2A plus B plus C whole square, and this will be B plus C minus A as it is, 0. This is minus B, this is 0. This is C plus A minus B. This is minus A, this is A square, B square, and this will be AB. So now what I'll do, we will expand it along C1, because now what do we observe? We cannot have any other zeros, as well as if I solve it up, I will not be landing into some useful result. So we will directly expand. So cross multiply. So this will be C plus A minus B will be multiplied with AB, and minus this will be plus AB square. Now next term is 0. So then this is minus B. If I cross multiply, what we will get? If I cover it up, this will be B square into 0 will be 0, and this will be A square C plus A minus B. So this whole expression is getting multiplied with this. Now let's quickly solve it up and see if I am getting something common. So from here, what do I observe? I observe that from the whole expression. This is one expression. Let me multiply first and then it will be clear to everyone. So this is whole. This will be multiplied with this as well as with this particular term. So we will write it as AB C plus A minus B is getting multiplied with B plus C minus A, as well as AB square is getting multiplied with B plus C minus A, and this is minus, this was this minus this, so this will be plus. So over here I will write plus A square B getting multiplied with C plus A minus B, this whole expression. So from all what we observe, we have three terms. What three terms? I have this term, I have this term, and I have this particular term. So from these three terms, can I take AB common? I have AB here, I have AB here, I have AB over here. So we can take AB common from the whole expression. So again the calculation will become easy. So I will take AB common. This will be A plus B plus C whole square. So we will write it again. I will multiply C with B, CB plus AB minus B square, then plus C square plus AC minus BC, then with A minus AC minus A square and plus AB. So after taking AB common, I have multiplied these two terms. Now for this particular term, if I take AB common, I will have only B. So this will be B square plus BC minus AB, and over here if I take AB common, I will have A. So I will write it as AC plus A square and minus AB. So this whole expression now I have. So what I will do, I will just quickly look for the terms which we can cancel over here. This is CB, so I can get cancelled with minus BC. This is minus B square, I can get cancelled with B square over here. This is plus AB minus AB plus AB. We have two ABs of this sort, so we can cancel it over there. Then we have C square, we don't have any other C square, plus AC, I can cancel with minus AC. Then we have plus BC, and then we have plus AC, plus A square and minus A square. So now let's see what left out terms I have. I have C square, I have BC, and I have AC over here. So I think now you know what we are about to get. So this is A plus B plus C whole square. So what do I have? C square. Then I have BC, all the terms that I have underlined, and AC. So now I can take comfortably C common. So what will I have? I will take C common and write it over here. A plus B whole square. This will be C plus B plus A. So again, what result I will have? 2ABC. A plus B plus C whole square. So the whole question was dependent on this particular expansion. If you do it nicely, taking things common in the steps, then you will be able to, this is whole cube, so you will be able to get the answer quickly. Clear? Now the next question, again very important question. It has been asked 4 or 5 times in board exams. Very important question, 6 marker. It can be a 4 marker question as well. So now what do we have? We have to prove this particular determinant equal to 2 results. Sometimes one result is asked, sometimes other result is asked, sometimes both the results are asked. So what will be the working? Now again, if I observe the question, if I add up along row and column, I am not getting anything. So now what I will do is, since I have maximum ones over here, I will try to make maximum zeros. So what I will be working on is, I'll write C1 such that C1 minus C3 and C2 such that C2 minus C3. So if I write it like this, what will happen? 1 plus A minus 1 will give me A, 1 minus 1 will give me 0, 1 minus 1 minus C will give me minus C, 1 minus 1 will give me 0, 1 plus B minus 1 will give me B, 1 minus minus 1 minus C will give me minus C. This is 1, 1, 1 plus C. Now what do I observe? Can I have one more zeros over here? If I try to make this as 0, what will happen? I'll lose either of the other two zeros. So if I add up like this, then also I'll lose some of the zeros. So what I'll do is now I'll simply expand. I have applied two operations, so I can expand. So if I expand it along R1, what will I get? I'll write A, cross multiply, cover it like this, cross multiply. So it will be B, 1 plus C, then 0 will be as it is 0. So I'll write 1, cover it like this. What will have? Minus C into 0 is 0 plus BC. So let's see what we are getting. This is AB plus BC plus C plus this is BC. So if I multiply it with A, it is AB, ABC plus AC plus BC. I have got the result. This result, if I want to derive this particular result, I'll take ABC common from the whole expression. What will I get? This will be 1. Over here, this will be 1 by C, this will be 1 by B, and this will be 1 by A. Hence the result. Although by applying two properties only, two operations only, I have got the result. So it does not matter whether you have to apply 6, 4, 5 operations, then only it will be a 6-marker question. Any question where you have to think for the first step, and the level of the difficulty is sometimes more than the other questions that we have done. So that questions are generally asked in 4 or 6-marker questions. Another very important question. This type of question is also there as solved example and in the MCQ of the miscellaneous exercise. Very important question. Whenever such type of question is asked, the result is generally 0. Now, how you have to apply this particular result, that is very important. This can be a 2-marker question. So now what do we observe? The question is given as we have to prove that the value of the determinant is 0 if alpha, beta, gamma are in AP. Sometimes it can be written as alpha, beta and gamma. Sometimes it can be written as ABC, no matter. But the result will be, most of the times it will be 0. So now what we have to do is, what we know when alpha, beta, gamma are in AP. We know that if alpha, beta, gamma are in AP, then 2 times of beta is equal to 1 plus alpha plus gamma, or we can write it as beta is equal to alpha plus gamma. Now everything is centered around beta, so beta is there in R2. So what I'll do is, if I apply the operation as R2 such that R2 minus R1, this is whole divided by 2, I will write the operation R1 plus R3 divided by 2. Let's see what happens. Now all the other terms will be same. Now if the result is 0, what we have to focus on? We can have equal, proportional, or any one row or column 0. So whenever it will be 3 terms are in AP, most of the times you will have that particular row or column where the middle term is present as 0. So that is the main thing that we have to remember. So if I apply this particular operation, let us find the element, what we are getting. Let's do it stepwise. So for R2, it is x minus 2. So first element is x minus 2 minus R1, that is x minus 3. R3, that is x minus 1 upon 2. So this is x minus 2 minus, this will be 2x minus 4 upon 2. So this is x minus 2 minus, if I cancel by 2, it will be x, outside we have minus sign, so it will be plus 2. So this and this will get cancelled. So what we will get? We will get 0. So I will write 0 over here. Now let's see for the second term. This is for the first. Now for the second term, it is x minus 3. We have x minus 4 plus x minus 2 upon 2. Again we will cancel. So this is x minus 3 minus 2x minus 4 plus 2 is 6 divided by 2. I will get x minus 3 minus x plus 3. So again it will get cancelled. We will get 0. So now everything depends on the last term. So let's see what we will be getting for the last term. So this is R2 is x minus beta minus R1 is x minus alpha plus x minus gamma R3 divided by 2. So over here it is x minus beta minus, this is 2x minus, I will take common, alpha plus gamma upon 2. So alpha plus gamma, in place of alpha plus gamma I can write 2 beta from here. So this will give me x minus beta minus 2x minus 2 beta upon 2. So now what will happen? X minus beta, I can cancel 2. So minus x plus beta. See the result. So again it is 0 since all the elements of a particular row are 0. Hence the value of the determinant is 0. So in most of the questions where you have 3 terms in AP, operation will also be same. You only have to look for the middle term. Wherever the middle term is, you will be adding the other 2 terms, other 2 rows or columns, and then you will divide by 2. You will always get the result as 0.